Hello and welcome to another video. In this video, we're going to be doing a sliding window for beginners. So I'm just going to go over how a sliding window works, when you should use it, and a bunch of example problems, assuming you've never heard of sliding window before. So first, let's go over when to use it. So you want questions that ask, like, what's the biggest subarray, or how many subarrays, or things like that, and it has to be contiguous. So contiguous means your subarray has to be in a row. It has to be something like this. It can't be like this combined. So that would be, yeah, so that's the main thing, is it needs to be like a contiguous chunk of a subarray. And then, like, what's the concept for the usage? So we can take an n squared task of, like, let's say we're asked, like, get all the subarrays that do something. So one way to do that is just brute force I and j for every single index, and then we can try every single one, right? So we can say, like, for I through this whole thing, for j through this whole thing, let's get every subarray from I to j. So that's n squared. But instead we can convert it to n time by having a right pointer. So what this is going to look like is we have a right pointer that's going to go one at a time, and we'll have a left pointer that's going to represent a window of where we're currently at. So the left and the right always start at 0, and then every time the right goes, the left can shrink to catch up. So like right now, let's say this is here, the left can shrink at any point, maybe it shrinks here and so on. So basically what's going to happen is the right will go all the way to the end, and then the left at worst will also go all the way to the end, which is linear time. And I'll show an example of this. And so what are the requirements we need to be able to solve the problem? So we need the condition on when to shrink the window, like when do we need to shrink the window, and we have to figure that out. We also need a condition for like what window is actually valid. And we need to figure out, like, okay, now that we have this valid window, like, what are we actually calculating? And so I have a template that we're going to use to actually code. So you basically do all your initializations. You loop through your, I guess this won't be a string, this will be the array, where the index that you're currently at will be the right pointer. You're going to do something with a current item. You're going to shrink the window if needed, and then you're going to check if the window is valid, then modify the result, do something there, and then return the result. So essentially, as you traverse, the right pointer will be like, out of all the subarrays that can make, I'm only going to include the subarrays that end at this point. So let's take a look at a quick example of a problem. So here's a flipped over one. Okay. So here's a quick example. So given an array of positive integers nums and a target, return the minimum length of a subarray whose sum is greater or equal to the target. If there's no such thing, return 0. So like I said, the brute force here would just be checking all subarrays, and that would be n squared. You just check all of them, you see like which one is bigger than the target, what's the smallest one. But we can use a sliding window here instead. So let's say our target is like 10. So we have to figure out, okay, like what's the condition to shrink the window? What's the condition for the window to be valid? And how do we calculate? So the condition to shrink the window is going to be if we can make it smaller and still, if we're greater than the target and we can make it smaller and still be greater than the target. The condition for the window to be valid is we have to be greater or equal to the target. And how do we calculate the result? We're just going to take a look at the length of our window and is it better than before. So let's just go over all the parts. So here we can initialize. The left is basically always going to be 0. We're trying to minimize the result, so let's make this like negative infinity, or infinity. And that's it. And we're going to actually have a running total as well, right? So we'll make that 0. So this is all the stuff we need. This is our initializations. So our left pointer will start at here. Our right pointer will start at here. And we're going to keep incrementing our total. And then we're going to shrink our window we're going to shrink every time we can. And we're only going to increment the result when our window is 10 or greater. So here, total is 1. So we don't need to shrink. Now total is 4. Total is 8. Total is 15. So now we can finally do something. So total is 15. So first we can see, can we shrink our window? Can we get rid of stuff and still be at 10 or more? So we can get rid of this. So we can move this over here. Now our total will be 14. We can also get rid of this as well. And our total will be 11. And now we can't shrink anymore. So this is a valid window. Our total is 11. It's bigger than 10. And now we're just going to record, like, what's the length of this? So this is 2. And then we're going to move on to the next thing. So we're going to say, okay, let's try this now. So now the total is 14. Can we shrink? Yes, we can. So we can get it down to 10. And this is valid. So we're going to record again. What's our total? Or what's our window length? It's 2. So same as before. So now we're gonna do it again. So total is 12. And then can we shrink? No, because that would make us below the total. And what's the total here? It's 3, and 2 is better than 3, so we're just keep going. Okay, now our total is 13. Can we shrink? No, because we'd fall under 10, so we keep going. Here our total is 19. Can we shrink? Yes, so we can go to 12. Can we shrink again? No, because then our total will be 9. So this is 4. The result's better than that, so yeah. So now our total is 21. Can we shrink? Yes. So we can get rid of all of these actually and subtract 6. So we get 15. Can we shrink anymore? No. Total 2, same. Now total 25. Can we shrink? Yes. So we can actually shrink both of these to make a total of 10. And a length of 1, which is better. And then we're just going to return our result of 1. So that would be the case. So essentially your right is just going to go one at a time. Then your left shrinks when appropriate. And you check, is my window valid? And if my window is valid, I'm going to make some calculation. All right. So let's do some examples now. So this is the one that basically I was talking about earlier. So this is literally that. So we'll just code that. So we're going to have a left 0 and total 0, result infinity. Okay. And we're going to go through all the numbers. So this is always going to look the same. So we initialize, we have a for loop. We're going to add our current number to our total. We're going to say, so this is also the same. So you have a for loop and then you have a while loop to shrink. Always going to be the same. Yeah, so while total minus the left thing, left is greater than or equal to target, will shrink. Yeah, so that and total, we have to actually do it the other way. So we'll subtract, then we'll go. Okay. Now we have to check, is our window valid? So we can even write this in steps. And we can just copy this to all our other problems. So this is initialize step, for loop step with right pointer, do something with current value, shrink window logic, modify result logic if window is valid, and finally return result. So we're literally going to just copy paste this to every other problem. So now if the window is valid, so if the total is greater or equal to 10, we're going to minimize the result. The window length for sliding window is always right minus left plus 1 if you just want the whole window, because like let's say we're here and here. So it's going to be 5 plus 1, so 6. So 1, 2, 3, 4, 5, 6. So that's like a good thing to note. And then, yeah, just return result. And we got the wrong answer, apparently. Nice. Good start. Okay, we got null. So the reason we got null is because if result is infinity, that means we didn't find anything. So if result does not equal infinity, otherwise let's return 0 because that means we couldn't find anything. Okay, we still got a problem. Interesting. Okay, we got 0. If there's no such subarray, return 0. Minimal length of a subarray. Okay, so in this case, there is actually a subarray. So let's see what we did wrong. Total plus equals v, while total minus numsl greater with target, totus. Okay. If, okay. So here it should actually be, yeah, it should be, what is it, like 2? Yeah, and let's see what we got here. So here we got 0. Okay, so we're basically just like not calculating correctly or something like that. Yeah, so let's see. Right v. Definitely doing something dumb as always. Total minus equals. Let's just print the total at every stage so we can like figure out what we're doing wrong. Okay, so we have 2, then we have 5, then we have 6, then we have 8. 2, 5, 6, 8, that's correct. Then we should have 11 or 12. minus some stuff. Right, 12 minus 5. Yeah, that's correct also. And then we have 7 as well. So that all looks correct to me. Let's also print the left pointer. Then that'll tell us everything we need. Okay, left pointer is at 4. So 1, 2, 3, 4. That's correct as well. So, oh, right. We don't want, I don't know why we did 10. Yeah, it's not 10. It's the target, right? Okay, there we go. I think we just had 10 for other examples. Why? So just, okay. All right, so there we go. So that one's good. Now we're just literally copy pasting this and going to the next. And we're just going to modify like everything we need. So here, given two strings, return true if S2 contains a permutation of S1, false otherwise. Permutation means that, yeah, basically like these letters are in this, in some order. And here it is true right here, right? So what are we checking? We're basically checking for whatever substring we're in, the letter counts have to be exactly the same. So we can, yeah, we can essentially do that. So first we're going to get the letter counts in our initialization instead of total. And so instead of total, we'll have a dictionary or something. And then we're also going to have, so this will be like S2 counts. So this will be the counts in the second word. And then we'll have S1 counts. And then in Python, you can use a counter of S1. So what this will give us is it'll give us a dictionary of letter counts. And then we're going to have a window that's going to be length of S1. And we're just going to check for that window. Those dictionaries have to be exactly equal because that means the letter counts are exactly the same. So here we'd have like 1A, 1B, and here we have 1A, 1B. And we can also have a check like if length of S1 is greater than length of S2, then obviously this is not possible. So we just return false straight away. I don't even think you need this, but whatever. All right, so now we're going to change things we need. So we have our initialization step. We don't need the result because we're just returning true or false. So we'll just return false if we were never able to do it. Okay. And then, so instead of total plus equals v, we're going to do nums, or not nums, S2 counts of the letter v plus 1. Then we're going to shrink our window if our window is at the length of S1, right? So like if we're at length 1 or more, we need to shrink because we need our window to be like, for example, here, we need to get rid of this letter. So this can actually just be an if, but we'll do while as well. So we'll do, actually let's change it to an if because in this case it will make more sense. So if r is greater or equal to length of S1, then we'll shrink. So then we'll do S2 counts, nums left, minus 1. And we'll delete the character if it's 0. So if the count becomes 0, we'll just delete. So if S2 counts this equals 0, we'll delete it. Okay. So now our window can only be valid when we are at length of S1 or bigger. Actually, sorry, at length of S1 minus 1 or bigger. Because let's say like length S1 is 4 characters, we have to at least have 4 characters. So right has to be S1 or S1 minus 1 or bigger. So if right is greater than or equal to length of S1 minus 1, then we'll do the check. If S2 counts equals S1 counts. So for this window, if all the letter counts are exactly the same, we can return true. Otherwise, we'll return false. Let's see. Oh, it's not nums anymore, so it's S2. S2 counts here. Oh, I didn't make it a default dict. We'll make it a default dict. And nums. This is S2, S2, S2. Okay. Okay. We're gonna copy this to the next because this one is a little bit different. Let's see. So we're gonna do the same thing. So here you're given a string in integer k. You can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operations. Okay, so the idea, like, I'm not going to go too much in depth of like how to do all of these, but the idea here is we basically want like whatever substring we have, the most common character we're going to keep the same, and then everything else will change to something else. So what we need to do here is basically keep track of like what's the most common character by doing a dictionary again. So you can notice for these, dictionaries are really good because if a string is like 1,000,000 characters, we can just store counts, and that's only 26. So essentially we're going to say like, okay, what's our biggest character count, and then we'll change everything else, and how many operations does that take? And if it takes too many, then we'll shrink our window. Okay, so initialize. So result. So we're looking for the biggest substring, so we can make this 0. We won't use total, we'll do counts. Okay, so we're going to take our current value and increment. And then we have to shrink the window logic. So what we need to do here is basically get the biggest character and then figure out how many other characters are there. And the way we could do that is we can do a max. Yeah, we can basically do a max. And then we'll get the rest of it essentially. So we can get all the counts combined, and then we'll do the max minus that, and that's how many we need. So we can just have a while true in here. So we'll modify this slightly. So first we need to get the character that occurs the most. So first let's just get like the values. So values equals, and this isn't going to be like the best performance, but this is still O of n because we're just taking we're only taking 26 characters here. So this is going to be counts values. Biggest is going to be max of values, and the replacements is going to be sum of values minus biggest, because biggest we can leave the same. Okay, and so if replacements is, so this is how many replacements we need. If it's greater than k, we can only have k, then we'll like move up our pointer. So nums, actually I need to do counts of nums, or not nums, s left here. Yeah, s left minus 1, and if counts s left equals 0, we'll delete it. Okay. And then we're going to move up our left pointer. And otherwise we'll just break, because then our thing is valid. Now, what's our logic to make sure our window is valid? So as long as we have less than k replacements, which we already have here, any window is valid. Like one character is fine, you know. So here just anything is valid. So we don't need this. And we'll do this. And then we'll just return res, because we can never have like infinity or anything. Okay, let's give that a go. This is s. Okay, we got something wrong. We got 0. Largest. Oh, we want max, right? Okay. All right. So yeah, like I said, there's definitely optimizations you can make here, but this is kind of just like the template you want to follow for all of these. So once again, we're going to take this, move on to the next. So here, we're asked for all substrings, or longest substring without repeating characters. Notice it's like substring, substring here as well, right? And then substring here as well. So we're always asked for subarrays, substrings, contiguous. We're never asked for like I never remember the difference, but subsequence or something, whatever one lets you jump, right? We have to have a continuous chunk. So yeah, so that's like the same patterns. Okay, so here we're doing the same thing. So essentially here, longest substring without repeating characters. So once again, like what are we doing here? So we can just store like a set or something to know if characters are repeating, and then whenever we get to a repeating character, we're going to shrink to make sure it's not repeating. So for example, if we have ABC and we try to store this A, we have to keep deleting from the left until we no longer have two A's. And same thing here, like if we get this B, we have to delete until we get rid of it, and so on. So that's what we need. We need a set or like a map or something. We'll go with the set. And result, we are maximizing, so we'll just make it 0. Okay, so we can do something. So you can add, so with a set, you can add it, but I'm just going to do the shrink window logic first. Because we want to basically check if we have this character already, let's shrink until we don't. So we're actually going to move this up first, then we're going to add it. If you add a map, you can add and then shrink, so small stuff there. Yeah, I guess let's actually show it with a map, because then we can follow this exactly. So let's go map. Okay, so do something with current value. So uniques v plus 1. So the shrink window logic is basically like while the count of uniques v is greater than 1. So while uniques v greater than 1, because we can't have duplicates. So we're going to go uniques at the left pointer, SL -1. Same thing, delete if needed. We don't really need to delete, like delete is also like, doesn't really matter, so we can just leave it, it's fine, it'll just go to 0, doesn't matter. Okay, so essentially we're just going to keep deleting until this count goes to 1, then we have a valid window. Now, what window is valid? Anything, as long as we don't have duplicates, which we took care of here. So we don't need this if, we just do this. And here we want the max, so we're going to max. And also here, there is no like return infinity or something, so. Okay. Cool. All right. And on to the last. So you see like all these things are like, if you look, we have a for loop, we have a while loop, we're doing something, we're incrementing the result. For loop, while, or I guess here we had an if because it only happens once, but this could be a while loop too, and then doing something with the result. Same, for loop, while loop, do something with the result, return. For loop, while loop, same, all the same. Last one. Given two strings s and t, return the minimum window substring, once again substring, continuous, such that every character in t appears in s. So essentially you just want like the small substring where all of these characters appear. So it's going to be very similar to the dictionary, so I'm going to in fact copy that one, because that's going to be the closest example. So instead of copying this one, I'm going to copy that one. It's going to be very similar. So essentially we need a substring where all of these characters are in here. So once we go, while we're going through the characters of S, for every character in here, the count in S has to be greater than or equal to the count in here, because that means all of these characters are in fact in here. So once again, there's some optimizations, but this will still pass, and this will kind of show everything we need. I don't know why. Okay, so instead of S1 and T, this is, so we can actually just rename. So we can go, just rename S1 to S. Yeah, let's do that. And let's rename S2 to T. Actually, we're looping, yeah, so actually S1 needs to be, or yeah, S2 needs to be S. And now S1, okay, screw that, whatever, we'll make it T. So essentially, actually, I think we can just go back, yeah, so, okay, so we want S2 to be S, and we want S to be T. And you can see, like, literally, I'm pretty much using all the same code. Okay, so how did I have T1? No idea. Okay, this really got screwed up. All right, I give up. We'll just rename. Okay, so if the length of T is greater than the length of S, then it's the same thing. We return false, because we can't have all the characters of T in S if T is bigger. So how do we initialize? So we're going to have S counts, and we're going to have, so this is S counts, and this is T counts. So we're going to do the same thing. We're going to get the count of every letter in T. We're going to have the for loop, where we're looping through S. We're going to add. So here, this actually needs to be a while. This needs to be a little bit different, so we're going to redo it. So here our shrink window logic is basically, let's see. I think we might want to make a while true again. Basically, we can shrink. Actually, yeah, so we can shrink as long as whatever character we're deleting, the count in T, like we already have. So for example, like if we have two A's, we can delete that. If we have two B's, we can delete that, and so on, right? So we can delete characters that we have too many of. So while, let's see, T, or I guess we can do one of two things. We can either shrink if the character is not in T, so while V, or I guess not V, SL, not in V, or T. So if this character is not in T, we can always shrink. Or, yeah, or, let's see, what's the other condition? Or SL, whatever the count is greater than TL. Yeah. This is actually not in T, this is T counts. And this is counts. So essentially, if it's not in T, we can always remove, and if it is, then it has to be bigger. Okay, then we can remove here. So then we can do S counts L, and we can do a deletion. So S counts L equals 0, delete. Okay, so now how do we check if our window is valid? So our window is valid if for every character in T, it's in S and the count is at least as big, right? So like we have to have at least one A, at least one B, at least one C. So we can check for that ahead of time. Like we can just have a check. So we can say like check equals true. And then for key in T, if key not in S, or this is not T, this is T counts, right? So if it's not in S counts, or S counts key is less than T counts key. Once again, there's optimizations you can do here, but I'm gonna ignore all that. I'm just gonna have a passing solution just to keep it simple. So essentially, for every key that we have, so for every letter in T, if it's not an S or the count in S is less, then it's invalid. So we can just say check equals false, and we can break. And now, so the check is going to tell us if our window is valid. So if check, then we can do the window. And then we're trying to get min, right? So, okay, so here, if there's no such substring, let's return the empty string. So we do want a result. So we'll make a result float infinity. And we'll just check, oh, we want the actual, so we want the substring. So if this is like small, we actually have to maintain like where the indices of the substring is. You don't want to store the entire substring, you can just store indices. So we'll just say like, let's see, we'll go with like res left, res right, or something, 0, 0. And we'll modify a little. So if result is greater than, right, minus left plus 1, that means this is a valid window, and this is the substring we want to return, and this is better than what we had before. So what do we call this? So this is going to be our pointers to our thing. So this is left, right, and result equals right minus left plus 1. Okay, so now we can just return S left to right if result greater than 0. Otherwise, let's return the empty string. All right, let's give that a go. Looks like we have an infinite loop. Memory limit exceeded. Probably infinite loop or something. Let's make sure. Let's see where it is. Oh, this is not left right. This is like resl, that thing, right? Resl. Don't think that's a problem, but let's find out. Yeah, I don't think so. Okay, so let's try to see if this is the problem. Okay, so that part is good. Let's try to, let's see. Let's try to comment out this guy, see if that's the problem. Yeah, I'm thinking the problem's here. Yeah, so if we comment out this guy as well. Interesting, the problem is actually here in the while loop. Okay, so let's look at the while loop logic. So while s counts L, not in t counts. This is not correct. So this should just be the character, while v not in t counts. See if that fixed it. Nope. Okay. While the letter is not in t counts, or sorry, yeah, no, this should be this would be SL. Yeah, there we go. Okay, there we have it now. Okay, we're getting an output 6 for some reason, so that's wrong. Don't know why. Oh, because we're returning here. But we're still returning the wrong thing. So we got Adobe. Yeah, so here we should be able to shrink if we have Adobe. Right? Because ABC... No, actually we can't shrink. Yeah, we can't shrink Adobe because we get rid of the A. So let's just... In this case, let's always print what we have. Yeah, let's just print what we have, just so we can get a better idea of where we're going wrong. So we have A, we have Adobe, and it never grows. Why is that? It's like, yeah, we literally never grow for some reason. And this is 6 characters, so we definitely have something wrong here. So let's figure out where it is. So S counts is fine. While SL, not in T counts, that's correct. This is correct. S counts L minus 1, L plus 1. Oh, right. This needs to be, I see. I mean, it shouldn't matter. I don't think. Let's find out. Yeah, it doesn't matter. Okay. For key in T count, if key not in S count, or S counts key less than T counts key, check with false break. If check, if result is greater than, we want smaller, right? Oh, no, it is smaller, okay. If result greater than, right, 1 plus 1, okay. Should be fine. Yeah, it seems correct. Curious what we got for these other ones. AA, false. That's fine. Oh, right, so we shouldn't return false. We should return the empty string there, so that'll take care of that one. Okay, so now this last one. So why are we not... Yeah, like, why are we not growing? Oh, we're not growing. Right, yeah. Okay, so we actually want to print here. Instead of this, let's go with this. So it'll give us a better idea, because this will give us all like substrings. Okay, so we have this whole big thing, but it doesn't shrink, and it easily can. Yeah. Why is that? This counts V. So we're not. So our shrinking logic is not correct. So while SL not in T counts clearly is. Yeah. Let's also print S counts and T counts. All right, so yeah, so down here, so here, yeah, so it is clearly in it. So that's not true. Or S counts key greater, which it is. Yeah, S counts L. Yeah, S counts L minus 1. All right, I feel like this is another kind of like a DP thing. I literally did something dumb, so we're just gonna throw it into GPT, and it's gonna be like a 1-line bug. Any logic issues? Kind of the same as before. It's just gonna be like I have a plus where you need a minus or something stupid. Okay, so in your while lines, you're using L. SL. Right, so that's 1. So S counts shouldn't be L, it should be SL. Same here, because we actually need the character. Same here. Okay. So that was 1. Okay, that was it, I guess. Oh, out of range, interesting. Okay, let's see why that is. Well, SL. Right, so this is the other thing I was thinking is we actually can't delete, like, like we might have characters that aren't in T at all, and we'll just keep deleting, and then we'll just be out of bounds. So what we need to do here is we need to also check while left is greater or equal to right, because we can't like delete if we're past our thing, and then we'll just throw this in an and then this should be fine. Okay. Oh, all right. ABA expected nothing. Interesting. So what would we have in this case? So here, what's gonna happen? So left is, yeah, that's correct. SL not, that's correct. And left, oh, I see. So here, I think what's happening is the left is actually past the right. So we'll have a check for there as well. So if left is less than or equal to right, I mean, this is good. That can definitely be cleaned up a lot, but I think this will fix it. Apparently not. Let's see. So let's print the left right here just to see where we're at. Yeah, it's definitely way messier than I intended. Okay, so left is at 1, right is at 0, just like I thought. So in that case, yeah, if left is bigger here, then we shouldn't do anything, right? So if left is less than or equal to right, which it's not. So how are we returning A? Flores is greater than 0. Yeah, that's interesting. Let's see. Have to run too many times. Okay, whatever. Okay, so yeah, how are we returning? Like, we're only modifying result here. So if less than or equal to right, I guess we can add it here. I mean, it doesn't really matter, but and well, I guess we still have some dumb bug. So if check and less than or equal to right, and yeah, all that. Okay, but we have it here. So this should just pass. So like here, like we shouldn't ever get in here, and we're not. Interesting. Okay, so we don't get in here. What do we initialize the result to? Oh, we initialize it to infinity. Well, that's okay. So this part is wrong as well. So this needs to be if s is less than infinity. So a lot of bugs. I guess a lot of problems. Okay, hopefully it's good now. Okay, there we go. So there's definitely optimizations you can make here, but you could see like how this works. And yeah, obviously this is a harder problem, but yeah, essentially, and like I said, there's obvious optimization, so I'm not going to care about runtime. But you should be able to see how we literally do the same thing every single time, right? So we initialize, we have a for loop for the right, we do something with our number, we have our shrink window logic, and then we have when do we actually modify the result. Yeah, so hopefully this helps for your future sliding window problems. Try it. I would recommend using this template for all your problems and seeing how this goes. So figure out your requirements, write the template, fill this in, and should be good to go. And honestly, for these medium sliding windows, you can see like, yeah, this one I screwed up a bit, but for the most part, you should be getting them in 5 minutes. Honestly, this one, if I don't screw up that much, this one is also like pretty. I mean, I've obviously done this problem before, but yeah, like if you've done the problem and use a good template, you should be able to do it in like 5 minutes. And if you haven't done the problem, just think of like these conditions. And like I said, the main thing we want to think about is contiguous and things like that. So yeah, hopefully this was helpful. If it was, please like the video and subscribe to the channel. And I'll be making more of these types of videos for like beginner things instead of just random problems. I think that's a little bit more helpful. So yeah, thanks for watching.